In this video, I'm going to do both number 13 and number 15 from page 656, since the directions are the same and they are of the same type of problem. We are asked to determine whether the sequence converges or diverges in each example, and if it converges, to give the limit. So for the first one, we're not given an explicit formula to determine the sequence. We have to come up with that on our own. So we have 1 over 1, 1 over 4, 1 over 9, 1 over 16. And hopefully everybody sees that the denominator is a perfect square. So our general term is going to look like this. A sub n will be 1 over n squared. So then we have our general formula. And so what we want to find out is, does the limit as n approaches infinity exist as a real number? That's what we want to find out. So in this case, what we're going to see is we're going to use our rules that we know about horizontal asymptotes, because that's what we want. We want this to flatten out, if it were a function that we would graph, to a specific number. So we're going to use our 3 rules that we have about the degree of the numerator compared to the degree of the denominator. So in this case, we have the degree of the denominator to be n squared. So it's squared. And the degree of the numerator is 0. So the degree of the denominator is greater than the degree of the numerator. So this function would converge to 0. So we know that L equals 0 and it converges. So now in the next example, we're given an explicit formula. So again, what we want to find out is, does the limit as n approaches infinity of 3n minus 1 over 2 minus 3n converge? And if this limit exists. So since the degree of the numerator and the denominator are the same, just have to catch up here. If you recall, our limit is going to be the ratio of the leading coefficients. So in this case, we have 3n minus 1. So that has degree 1. And in the denominator, we have 2 minus 3n, which also has degree 1. So our leading coefficients are here and here. So our limit is going to be 3 over negative 3, which is negative 1. So that's our L. So again, this sequence converges, and its limit is negative 1.